So, good evening, everyone. I welcome you all to live session number 12 for the NPTEL course Energy Conservation and Waste Heat Recovery. So, today we are at our last, or you can say last week, week 12 live session. Okay. So, it's 3:31 now. So, let's wait for another 4 minutes. After that, we will start. Let's wait for some students to join. After that, we can start. And just for information, tomorrow there will be a one more session that will be like you can say a wrap-up session. So in that session, we will discuss about the past week's classes. Okay. So maybe in that you can ask some doubts, and we will go through all the weeks. So I hope that will be beneficial to you, and that will be very helpful in your exams also. So please join that session tomorrow, and time is same 7 p.m. to 9 p.m. Okay. So I welcome you all to live session number 12 for NPTEL course Energy Conservation and Waste Heat Recovery. So today we are going to discuss about some sample problems for past week, that is week 12, and we will go through some concepts also. So this will be very beneficial to you in your upcoming assignments and in your upcoming exams. Okay. And this session is being recorded, so the recording will be shared to you from the NPTEL team, and the PPT that I am using will be also shared to you. Okay, so let's begin with today's class. So the question number 1 is, over the years, the EROEI, so a very quick term, EROEI value of oil is. Options are increasing, decreasing, constant, and unknown. So take 2 minutes to answer. First of all, what is the EROEI? Try to think about it. So EROEI basically for energy returned and energy investment. So the full form of EROEI is energy returned or energy invested. So now maybe you can recall. So over the years, the EROEI of value of oil, like you have to compare like what were the EROEI value initially when oil discovery was there, and you have to compare it as of now. So like it's increasing, decreasing, or constant or unknown. Okay. So do we have any answer? Okay. So let's go through the answer. So the correct answer is option B, decreasing. So basically the EROEI value, energy return on energy invested value of oil is decreasing over the years. Okay. So initially it was very high and now it's very low. So the EROE value of oil is decreasing with time as the energy cost of extraction of oil from the wells. Point to be noted, the energy cost of extraction of oil from the wells is increasing due to deeper wells and requirement for larger machinery. The oil that was more readily available in larger and shallower oil wells has already been extracted and consumed due to greed of mankind. Okay. So basically, initially when oil was discovered, it was very easily available. Okay, it was available in very larger quantity. So we don't need we never needed large machinery and all. So the EROI was very high. Actually, you have to invest like only 2 or 3 barrels, and you will get maybe energy content of 100 barrels. But as the time passes, we have, due to the greed of mankind, we consume so much of oil. Now the due to deeper wells and requirement of larger machinery, the cost of extraction has been increased. That's why the EORI value is decreased now. Okay. So over the years, the EROEI value, like energy return on energy invested value of oil is decreasing. Okay. Any doubt? Yeah. Hi, Alok. Is my sound, PPT, and everything is okay? Video?
Yes, sir.
Yeah. Okay. Thank you. So the question number 2 is, which of the following matrices of energy does not consider time value of money? ROI, payback period, LCOE, NPV. So which of the following matrices of energy does not consider time value of money. Very important term, time value of money. First of all, you should know this. What is the time value of money? And return of investment, payback period, levelized cost of electricity, LCOE, and NPV, net present value. So take 2 minutes and let me know the answer. Any answer, Alok?
Yes, sir. Rate of value and playback periods, I think.
Okay. Okay, nice. So do you want to like discuss time value of money? Like what is the meaning of time value of money?
Sorry, sir, I don't have any idea.
Okay, nice. Okay. So basically the time value of money is like when we are considering the matrices of energy. Okay. So suppose there is a power plant and we are installing a power plant, or any company is installing a power plant. So so that power plant will be there for more than 20 years, 25 years, okay, 30 years, 50 years. It depend on type of power plant, technology of the power plant, okay. So the main point is that their power plant is there gonna be for many years, okay. So but now we are investing. Uh, so today we are investing in that power plant, okay, and that power plant will be there for so many years, and there will be like we are getting some returns from the power plant. So suppose today you are investing uh 1 crore rupees, okay, and after 5 years you are getting return of suppose 3 crore rupees, okay. So now you have to consider like today there will be a difference, okay. So the value of 1 crore that is today, that will not be the same after 3 years, because the money devalued with time, okay. The value of money decreases with time. So we have to consider that, okay. So whenever we are finding the energy cost, whenever we are finding the total like what will the payback period, and we are do, and suppose when we do the techno economics or like economic analysis of the plant, then we have to consider the time value of money, because with time the value of money changes. So we have to consider this factor. So after considering this factor, we can find out the correct values, that the investment that we are doing right now. So what will be the this investment will be equivalent after like 10 years, 15 years, and suppose after 10 years if we are getting this much of return, then that return like is for how much money is like that equivalent to in today's perspective. So we have to consider that. That is the time value of money. So now the options are return of investment, okay, payback period, and levelized cost of electricity, and net present value. So the payback period and the return of investment does not consider the time value of money, okay, but the levelized cost of electricity and net present value, they consider the time value of money. So actually in these two we are using a discounted rate, or you can say inflation rate, because we know that every year inflation is increasing, okay. So there should be some inflation. That's why we consider like a discounted rate term in the calculation of LCOE and NPV. But we don't consider any term regarding the inflation in the return of investment and payback period. In these, we only consider So like what is the cost now and what will be the in future? We are not considering the time value of money. So the correct answers are option A and B. For more detail, please refer to lecture 62 and 63. Any doubt? Okay. Question number 3 is for the viable industry in terms of economics, NPV, net present value, should be equal to 0, greater than 0, less than 0, and none of the above. So take 2 minutes and let me know the answer. So do we have any answer?
Yes, sir. In lecture, sir has told that NPV value must be greater than 0 for economic viability.
Yeah, correct. So what is the NPV, net present value? Like a single line definition? Okay. So basically NPV, okay, is net present value, or we can also say, or it's net present worth. Okay. So basically it is the difference between the present value of cash inflows and the present value of cash outflows over a period of time t. Okay. Because suppose whenever like we are planning to set up a industry, then we will do the its economic analysis. So in that we will do some economics like how much money we have to invest and how much money we will get in return. So that is the difference between the present value of cash inflows and the present value of cash outflows over a period of time t. And the simple formula for NPV is RT upon 1 plus I to the power t. So here RT is the net cash flow. Okay. Difference between the inflow and the outflow, net cash flow over time t, and I is the discounted rate and t is the time. So this is the net present value. So it will be like so means NPV is difference between cash inflow minus outflow. Okay, so inflow means like revenue you are getting, outflow means the investment. So if the NPV will be greater than zero, it means that your inflow is more. Okay, so you are getting more revenue. Okay, net more revenue than your investment. Okay, so the NP value should be as high as possible. That will be beneficial for our industry. So the correct answer is an economically viable industry should have a net present value always greater than zero, which corresponds to a profitable business. Okay. So if NPV is greater than zero, it means that business is profitable. If NPV is equal to zero, it means that you are at break even. Okay. So means that your uh, net invested money uh, just returned to you. Okay. So if greater than zero, it means that now you are getting profit. You have recovered your all invested money, and now the money that is coming will be your profit. So that the NPV should be greater than zero for economic viable industry. Any doubt?
No,
Okay.
sir.
So LCOE is useful for levelized cost of electricity is useful for determining rate of investment, choosing discount rate, comparing competitiveness of different energy installation, and calculating tax rebates. So you have to answer like regarding the LCOE, levelized cost of electricity, and another matrices to do the economics of a plant. So think about it and let me know the answer. Do we have any answer?
Yes, sir. It is the helps in comparing installation in a level playing field, sir,
Okay.
at the competitiveness of different energy installation.
And what is your reasoning?
According to the Energy Infrastructure Administration USA, sir has told that it helps in the overall competitiveness of energy generating different generating technologies, sir. Exactly, I don't
Okay.
have any extra explanation, sir.
Yeah. Okay. Yeah. Nice. Okay. So let's go to the answer. So basically, the levelized cost of electricity offers a level playing field. Okay. So a level playing field, it means that it can compare different technologies for comparison of cost of production of energy over the entire life of an energy installation. Some energy plants have high installation cost, but low maintenance cost like solar wind. Because when we are talking about solar and wind, so these are having very high installation cost because solar panels are very costly, wind generators are also very costly. But after that, we don't need any operation cost. Okay, we just like regarding in solar, we just need to clean it, and we don't need to put fuel in it because it's solar edition. It's easily available. Then for the wind, we just have to install the wind tower. After that, we have to do nothing because wind is blowing, the wind turbine will rotate and generate energy. So that these are having high installation cost, but they are not having very high operation and maintenance cost. On the other side, some have lower installation cost but higher operation and maintenance cost like coal or natural gas based plants. So these plants are very easy to install because the technology has been already matured. Okay, they are readily available. We can install them easily. But to run these types of power plant, we need to put energy in. We need to put the fuel. Okay, so that there will be fuel cost. So when we are uh, because these plants are also limited by thermodynamics. Okay, so there will be efficiency limitation and there will be like combustion and everything will be involved. Okay, so we have to there will be more maintenance due to the boiler, due to the combustion, due to the engines, due to generators and many more equipments. Okay, due to more complexity, there will be more operation maintenance cost. Okay, while some have high disposal cost like nuclear. So nuclear, the disposal of nuclear plant is very costly. Okay, so that we need a level playing field. So you have seen that for energy generation, there are different types of plants. So we need a level playing field. From that only we can generate, we can compare which plant or which technology is best. So that is the levelized cost of electricity. So basically, it will be the cost of electricity per kilowatt hour. So you can say dollar per kilowatt hour or rupees per kilowatt hour. So this will be the unit of LCOE. So from this, we can find out that for to generate 1 kilowatt hour of energy, we need this much amount of money. So that's very useful actually. If we know this, so based on this, we can also decide the selling price so that our company or our plant will be in profit only. Okay. So the correct answer for LCOE is useful for comparing competitiveness of different energy installation so that we can compare different energy installation like solar, wind, coal, nuclear, and many more. So this is a very useful tool. So the correct answer is option C. Any doubt? Okay. So let's go to the next question. So a new oil well gives 200 billion barrels of oil. However, the cost of recovering the oil is equivalent to 50 billion barrels. Calculate the EROEI, energy return on energy invested. So you have given like we have to give 200 billions barrel of oil and the cost of recovering the oil is equivalent to 50 billion barrels. So what will be the EROEI? Go through it and let me know the answer.
Hello, sir.
Yeah, yeah, hi.
Sir, as we know that EROEI is equal to energy output upon energy input. So
Okay.
energy output will be 200 and energy input will be 4. So if we calculate, then answer will become 4, sir.
Okay. Yeah, nice. Let's wait for another 1 minute to calculate for to the answer for other students.
Yes, sir. 4.
Okay. Okay, so Aman Tiwari, I think you this is your first class, Aman, or your like second, third class?
Second, third class.
Okay, okay. So if you want to introduce yourself, so we can know you.
Sir, I am Aman Tiwari. I am a student at Madan Mohan Malviya University of Technology, Gorakhpur, in Mechanical Engineering Department.
Okay, nice. So student of like bachelor's, master's, PhD.
No, sir, bachelor's.
Okay, bachelor's. Nice, nice. And what about you, Alok? Actually, I forgot about you. I think you have already introduced, but please repeat.
My batchmate.
Okay, so both of you are in same college.
Yes, sir.
Yes, sir. We are in same college, sir.
Okay, okay, nice, nice. So you have joined this course as part of your like coursework or what? Like you are just you are having some interest in this course or like
Sir,
Yes, sir.
program
We have.
electrics.
Yes, sir. We have an interest in thermal. That's why we all have chosen energy conservation based category because almost of
okay,
the topics are covered in GATE also, sir. We are in focusing GATE also, sir.
okay, okay. So you are in maybe in fourth year, third year, third year.
We are in sir final year, sir, fourth year.
Oh, yeah. Okay, 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 okay. Nice, nice. It's a very good course also. Yeah. So as you said, so EROI is basically energy out and upon energy in. Okay. So basically here you can see that a new oil well gives 200 billion barrel of oil. However, the cost of recovering the oil is equivalent to 50 barrels. Okay. So the energy out upon energy out is 200 billions and energy in is 50 billion barrels. So we are getting 4. So to get this much of energy, like to get the energy of 200 billion barrels of oil, we have to invest 50 billion barrels. So anyone want to tell me like what is the meaning of like where this investment going actually? Like where this energy will be used? Like because normally we know that energy cannot be energy is conserved. Okay, we cannot it can only change form. Okay, we cannot decrease it, we cannot increase it, we can only change it. So how can we inputting only we put the input of 50 billion and we are getting 200 billion. Today we are having 3 students who have joined online. So I want to discuss with you. Please share your thoughts about it. Anyone? What is the meaning of this? Like energy out, energy in. What is the like meaning of this?
So the net energy that is used by us, we are using, and the total energy that is invest for tomorrow and building many buildings we are using runs our refrigeration and other equipments in
Okay.
the power plant.
No, no,
Uh,
no, no. You are going in wrong direction, I think. Anyone else? It's a very actually very important question. You need to understand it. So basically the question is you are getting 200 billion barrels, okay, energy out, and you are investing 50 billion barrels. So what is the meaning of like you are getting or what is the meaning of like you are investing? So what is the like main difference between these two? It's very important actually. Yeah, yeah, please discuss. No issue. If you don't know, no issue. Because if we discuss it, then your doubt will be cleared actually. So discussion is a very good thing. So normally we don't have so many students, but today we are having 3. So Aman, any thoughts about it? Akash?
Sir, as we know that if our output we getting is we will be benefited as we are getting as we are applying low matlab, it means minimum input we are giving and output we are giving getting very high much, so we will
Like
be benefited as
no, no,
according
just
to the
yeah, Yeah, it's okay, but give me a like real example. Like, suppose I am not from engineering background. Now you have to explain me that what is the meaning of this energy in, energy out, just in a simple language. Like we are discussing about oil wells. Okay, so explain in terms of like oil extraction, oil equivalent, like that. Okay, so let me explain you. So basically, the energy in means the energy invested. Okay, and the energy out, that is the energy available to you. Suppose you are having a oil well. Okay, so this is a oil well. There is so much of oil. So you know that you can generate power from oil. Okay, you can convert the oil into petrol, diesel, and many other fuels. Okay, so but you need to extract the oil. So for extraction of oil, you need some kind of machineries to purify oil. To purify the oil into petrol, diesel, you need some kind of refineries. In refineries, you will use some energy, you will use some process. So that is the meaning of energy invested. Okay, so you have to invest 50 billion barrels of oil equivalent. Okay, then you will get in return 200 billion barrels of oil. So basically, just in simple language, suppose you need to pump out the oil from well, so you can pump out 200 billion of oil to 200 billion barrels of oil, but you give to input, like if you are having a pump here, so that pump will consume 50 billion barrels. That's a basic simple definition. That suppose this is the tank, you need to install a pump. That pump can pump out the liquid out of the tank. So you can pump out 200 billion barrels, but to pump out, your pump need electricity or power. So for that power, you need to invest 50 billion barrels. So basically, 50 billion, with the investment of 50 billion, you are having 200 billions of energy. Suppose now you are having 200 billions of oil. So it means that you can run how many pumps? If one pump required 50 billion, so you can run four pumps. Okay. So mean you can run four pumps. So you can put out you can like drain out four oil wells to get more oils from those wells. I think now it's clear to you. Any doubt?
No, sir.
Okay.
No, sir.
So yeah, this is the energy invested and energy out that we are getting in return. So question number 6, input output analysis was developed by a theoretical question. Philip Kotler, Wesley Leontief,
Vasily
John F. Wells. Yeah.
Leontief.
Yeah.
Okay. Yeah. Let's wait for just 1 minute. Okay. So let's see the correct answer. So the correct answer is answer B. So Wesley Leontief was the inventor behind the input output analysis. A numerical, good one. So a thermal power plant has a maximum load of 150 megawatt and an annual average load factor of 0.7. Calculate the revenue generated from energy cell per year if energy is sold at Rs rupees 10 per kWh. So go through all the data and let me know the answer. Take 2-3 minutes. So we have given a maximum load. First of all, you have to look into this and an annual average load factor. So you have given like energy cell per year if energy sold at 10 per kWh. So I think you should know you have to convert the megawatt into kWh. So those who are preparing for GATE, it's a good question for you. Maybe you can directly solve this question with the unit balance. I have already, I think, in one of my class, I have told that method. Like if you are having a numerical, so if you are like not sure how to solve this, then you can try to solve with units. So the units are very simple here. So you have one unit in like rupees per kilowatt hour. Okay. And this unit like maximum load in megawatt. And you have to find the answer in rupees. So basically it means that you have to multiply this and this. But you should know that which value should multiply because you have given load factor also. So here comes like the concept. But basically you know that you need to multiply this and this. But again, here you will see this unit is in megawatt, this is in kilowatt hour. So it means that you should convert it into megawatt hour. So if you convert it in megawatt hours, it means that you have to multiply with like multiply with time. Okay. So you have given like your power plant has a maximum load of 150 megawatt and annual average. So in a year there is 365 days and 24 hours. Okay, so this will be the total number of hours in a year. Maybe you can multiply this with this megawatt, so you will get the complete energy. That will be in megawatt hour. Now you can convert this megawatt hour into kilowatt hour. Then you can multiply with this, and you have to also multiply the load factor. Because generally you will get multiply when 150 into zero point 0.7, so that will be the average, you can say the average energy, average load on the system. So after that you can find out the answer. So let me know the answer. I have given you a very good hint. Any answer?
Sir, 0.9198, I think.
0.91.
98.
Yeah. So you can see the options. We are options in crores. You have to convert into crores. That's again a very like big point because whenever you are dealing in GATE also, just I'm saying you like if you are preparing for GATE, always take care of units. Okay, so unit should be in streamlined manner. There should be like in every, you have to check the every unit because like you are saying the answer is 0.9, but there is no option. But maybe in GATE there will be an option for that also, but that option will be wrong because the correct option will be only like in crores. Okay, so 919A, I think this will be the answer from your answer, but it's in 919. So you have to convert into crores. Convert it and let me know the answer.
Sir, 919.8.
Yeah, nice. 919.8 crores. Very good. So basically, in this question, you have given like 150 megawatt of annual demand, okay, with a load factor of 0.7. So the load factor you have to like what will be the average load, because sometimes the plant will have like we have already discussed in our previous class that during the like morning time the energy demand is very high, during the night time because everyone is sleeping, okay, so energy demand is very low. So on average the demand load is 0.7. So whenever like we have to find out like what will be the, you can say, the cost for per year, then we have to take the average load factor. So multiply this factor with the total the capacity like maximum load. So you will get 105 megawatt is the maximum load of your plant per, like it's like energy, it's not in hour or anything. Now you have to like find out it's only load in megawatt. So you have to find out the energy generated per year. So that now you can multiply with 365 and 24 hours. So you can, your plant is generating 919 919,800. Okay. So basically 91,900 9,800. Okay. 9 lakh 19,800. So 919,800 megawatt hour amount of energy your plant is generating. Now you have given like the energy cost is Rs 10 per kilowatt hour. So you have like this kind of energy is generated from your plant in a year. Okay, like in kilo in megawatt hour. So just multiply it. Okay, and this is megawatt hour. This is per kilowatt hour. You have to multiply with the. You have to be careful with the units also. So it will be 919.800 into 10^7. So it will be in crores. So the answer will be 919 crores. Any doubt?
No, sir.
Okay, yeah, good. So from the previous question, calculate the net annual cash flow if coal consumption is 0.9 kg per kilowatt hour of energy generated and cost of coal is 1000 per ton. So you have to use the data from previous question only. So you can note down the data that is required. So from the above question, calculate the net annual cash flow if the coal consumption of 0.9 kg per kilowatt hour of energy generated and cost of coal is Rs 10,000 per ton. So these are data from the previous question. If you want to note down, please note down this data because this data will be useful in your next question. Take your time and let me know the answer. Any answer? Anyone? Are you calculating? So first of all, I think you have to find out the amount of coal required. Like what will be the amount of coal required per year? So that you can find out from this, because you know the energy requirement of energy generated per year. Okay. So like 9,19,800 megawatt hour energy is generated per year. So to generate this much of energy per year, how much of coal is required per year? So because you have given zero point 0.9 kg per kilowatt hour of energy generated. So zero point 0.9 kg of coal is required for per kilowatt hour of energy. So you have generated 9,19,800 megawatt hour of energy. So just multiply these things with, be careful with units because that is in megawatt hour, it is in kilowatt hour. So you will find out the amount of coal required per year. Okay. After that, you need to find out the cost of coal. So you have given that the cost of coal is 10,000 per ton. So you can convert the quantity that will be in kg to ton and you can multiply it. So that will be your cost. Okay. And you already know the revenue. So the revenue is 919 crores. So the net cash flow is in minus out. So revenue in minus total investment. So your revenue, you know the investment, that will be the cost of the coal. You can calculate. So if you subtract these two, you will get the answer. So this is a very good hint. So take another 1 or 2 minutes because this is very important, because maybe you can find similar numericals in your exam also, in your GATE exam also. Let me know the answer. Hello, Aman, any
Yes, sir.
answer?
Calculating.
Okay, calculating. Okay, take your time. Okay, just 1 more minute. After that, we will discuss it. Just find out the amount of coal required per year. then find out the cost of the coal per year. Then you will know net annual cash flow.
Sir, I think 91.89 crore.
Okay, 191.89. So the option will be option, which option?
C. C, sir.
Option C. Okay, very good. Let's see the answer. So yeah, it's correct. So the correct answer is C. So as I told you, first of all, you have to you have to find out the amount of coal required. Okay. So we have given like coal consumption is 0.9 kg per kilowatt hour. In previous question, we know the total energy generated will be 9,19,800 megawatt hour. So just calculate, just multiply that and convert that into kilowatt hour. So multiply with 10 to the power 3, then multiply with 0.9. Okay. So that you will know, like you will require 827820 multiplied 10 to the power 3 kg of coal. Convert into ton. So you will require 827820 ton of coal per year. Okay. Now you know the cost of coal is 10,000 per ton. So multiply this like this amount of coal in ton multiplied by 10,000 per ton. So the answer will be in rupees. It will be 827 into 10 to the power 7 rupees. Okay. So from previous question we know that the revenue is 919.800 multiplied by 10 to the power 7. So the subtract these revenue minus your cost. So it will be the net annual cash flow. So you will get 92 crores. So approx 92 crores, like as Alok said, 91 point something. So the correct answer is option C. Okay. So this will be your annual cash flow. Any doubt? Anyone? Okay. So question number 9. So an energy installation cost is Rs 1.313 crores. Cash inflows over next 5 years is expected to be Rs 30 lakhs over first 2 years, 45 lakhs over next 2 years, and 75 lakhs in the fifth year. Assuming a discount rate of 15% and zero salvage value after 5 years, calculate its NPV. You have to calculate the net present value. So you have given the energy installation cost, okay, and the cash inflows you have given. You have to calculate the NPV. So NPV is basically the cash outflow minus cash inflow. Okay. Sorry, cash inflow minus cash outflow. So you have given the energy installation, that will be the case. You can say the outflow will be 1.313 crores. Investment, your investment. Cash inflow, you can calculate. For cash inflows, the formula is R upon 1 plus discounted rate to the power time. So this is the amount of your cash inflow. The discounted rate, this is time. So you have given like 30 lakh for 2 years, 45 lakh for 2 years, and 75 lakh for fifth year. So you can use this formula to calculate the total cash inflow for 5 years You know the case outflow, so the net value NPV is case inflow minus case outflow. In that way, you can calculate the NPV. Let me know the answer. So this, let me give you another hint. Suppose if you want to calculate for 30 lakhs first cash flow for first 2 years, maybe you can do like this 30. So you can all like convert in crores also. So 0.3 crores upon 1 plus discounted rate is your 15%. So 0.15 is for, you can say, 30 lakh over the first 2 years. So it will for first year, and again 0.30, 1 plus 0.15 for second year. Like this, you can do for third year, fourth and fifth year. Are you calculating, Alok?
Yes, sir.
Okay, okay. So you have 2 minutes. After that, we will discuss. Any answer? Okay, 1 more minute, Alok.
Sorry, sir, my answer is not matching any of the given answer.
Okay, no issue. So, see the calculation then. So basically, we have to just calculate, like we have given the NPV. Okay, we have given the like data for NPV calculation. So 30 lakh for first 2 years. So this is the like NPV for first year for 30 lakhs. Then for second years, then for 45 lakhs over next 2 years. So this is for 45 for third year. So 1 plus discounted rate to the power third for third year. This is for fourth year. This for fifth year. Okay. And the salvage value is 0. Okay. 0 salvage value. That's why 0. And then the outflow is 1.313 minus 1.313. So these are in both are in crores. So if you calculate these terms and subtract it, then you will get 0.1 crores, or you can say 10 lakhs. Alok, you can try this in calculator, I think.
Yes, sir.
Please let me know the exact answer. What is the exact answer?
Ten lakhs, sir.
Okay, nice. Okay, so I think we can go to the other question. Any doubt?
No, sir.
Okay. Question number 10 is the installation cost of an energy equipment is Rs 22 lakhs and estimated operation and maintenance cost is Rs 70,000 per year. Okay. Estimated saving is Rs 7 lakhs per year. Calculate the payback period in years. So you've given the installation cost, you have given the saving. So just calculate the payback period. I think Alok, there are today there are so many numericals for you. So basically, you have given the operation and maintenance cost per year, okay, and savings also in per year. So you can find out like what will be the payback period. So I think first of all you have to find out net saving per year, like how much net saving is occurring, because there is operation maintenance cost and total saving that they have mentioned. But net saving will be the total saving minus operation maintenance cost. So in that way you can find out the total net saving per year. So you know your net saving per year, you know the like installation cost. So the payback period will be like the years in which you will recover the invested money, and the invested money is 22 lakhs, and you know the savings. So just you, I think you have to divide it, so you will find out the number of years or payback years. Do we have any answer?
Sir, please explain how to approach.
Yeah, so see, you have to find out the payback period. Okay, so you have given the installation cost. Okay, so that will be your like investment. So the meaning of payback period is the time in which you will recover your investment. Okay, so first understand the theory of it. So you are saving something. Okay, you are like getting some revenue every year. So you have given estimated saving is 7 lakhs per year. So basically you are saving 7 lakhs per year. Okay, but there is operation and maintenance cost is also involved. That is 70,000 per year. So first of all, you have to find out the net saving. Okay, because operation and maintenance cost is also a kind of investment, or you can say recurring investment, because you have to run your setup. So that's why you have to invest it. So it's a recurring type of cost. So if you have to deduct this cost from your savings. So after deducting it, you will get your net saving. So now you have your net saving, okay, and you have your net investment. So you know that you have to invest, you have invested 22 lakhs and you are saving suppose 5 lakhs per year, net 5 lakhs per year. So just you have to divide it, because suppose you will save first year 5 lakh, then second year it will be 10 lakh. Okay, cumulative sum. Third year it will 15 lakh. Fourth year it will be 20 lakh. And after fourth year and before the end of fifth year, you will have 22 lakhs. So that time will be your payback period. So that with this much saving, you will get your invested money back in the this much of time. That is the payback period. I think now I have already explained you everything. I think the answer, just calculate it. Do you understand my point or not? Am I clear? Okay, so let's see the answer. So as I told, you have to find out the net savings per year. So you are saving 7 lakhs per year. So 7 lakhs, but you are also occurring operation and maintenance cost. So you have to deduct this for net saving. So the net savings per year will be 7 lakhs minus 70,000. So you will get 6.3 lakhs. So this 6.3 lakh is your net saving. Okay. And you have invested 22 lakhs initially. Just divide it. So 22 upon 6.3. So you will get 3.5 years. So in exact 3.5 years with 6.3 lakh savings per year, you will get 22 lakhs. Okay. So it means that this 3.5 year is your payback period. Payback period for what? Payback period for your invested money. Okay. So this is your payback period. So the answer will be D. Okay. And the payback period in years is always the year where we reach break-even point. Okay. So this will be the break-even point. So at this point, at 3.5 years, it means break-even point. It means that invested equal to profit. So the money you have invested become equal to the your net profit. So basically, you have recovered all your invested money. After 3.5 years, every penny that you will get, that will be your net profit. Okay, that will be your net profit. Okay, so I think it's clear. So one another point is here that this payback period method is not considering the net present value, because like after 3 years the value of 22 lakh will not remain the 22 lakhs. Okay, in terms of like counting, it will remain 22 lakhs only. But if we consider like what will be the market value of this money, so it will decrease. Okay, so that's why we have to consider, because suppose if you can put this amount in your bank and you can get some interest on it. Okay, so you have to consider that. Okay, you are just getting only the same amount of money after 3.5 years, but it should be not the same, it should be more. Because if you have, suppose before 3.5 years you have invested this money into share market, or invested this money into like in FD or any bonds or anything. Okay, so maybe you will get return of 8%, 7%, or 6%, some return you will get. So that return is showing that this your 22 lakhs is increased to maybe 25 lakhs in 3.5 years. So after 3.5 years, the value should be 25 lakhs. But still you are making it 22 lakhs, then there is an like calculation is incomplete. Okay. So that's why we have considered the levelized cost of electricity and all different methods. So because they are also considering the time value of money. I think we have covered a question about this also earlier. Is it clear, everyone? Any doubt? Hello? Any doubt?
No, sir.
Okay. So next question is, what is the drawback of payback period as a metric of energy economics? In last question, I have discussed it. Yeah. Anyone? So the last question that we just recently solved, that was depend on
Does not
payback period.
consider time value of money, sir. So does not consider time value of money, sir.
Yeah, nice. Let's wait for
Option
another 1
B.
minute. Option B. So we have an answer option B. Anyone else want to answer? So allow just for information, tomorrow we are having another session. Okay, like wrap up session from same time 7 to 9 p.m. So in that session, we
Okay,
will
sir.
discuss about all 12 weeks. Okay. So
Okay,
like
sir.
this course was only for 12 weeks. So as of today, as per course, this is last class. But tomorrow also we are having one more class. So in that class, we will discuss about every weeks courses. Okay.
Please
So I
suggest,
hope.
sir. Actually, we have an exam in 28 October, sir, of energy conservation and waste recovery. So
Yeah.
we have afraid how to approach in that examination. Actually, sir, examination pattern has been changed, and some fill in the blanks are also will come.
Yeah. So it will be very good for you to join the session because in that I will discuss different types of questions. So in those questions, there will be fill in the blanks also, match the followings also. Because I think you have not covered my all classes. So we have covered all types of questions in our discussion actually. So it will be very beneficial for you to join that session. So please tomorrow 7 to 9 p.m. we are going to discuss so many of questions.
Sir, if we do all the assignments and your live session questions, then we will be able to get good marks in the examinations.
Yeah, because if you are able to go through the assignments, then I think your concepts will be clear, and the exam will be also like there will be like similar questions like from assignments or from the course content only. So you can easily pass that exam, no issue. If you have gone through if you have gone through the professor videos, if you have done your assignments, then I think it will be very easy for you. Okay, so the answer
Yes.
for this question
Thank you, sir.
is does not consider time
Option
value of money. Yeah, look, please. Yes. Alok, you were saying something?
no, sir.
Okay. So the answer for what is the drawback of payback period as a metric of energy economics is that it does not consider the time value of money. And this is also we can see in this question because in this question, as I told you, because the 22 lakh rupees is just coming in 3.5 years as same amount. But if we have invested in somewhere else, we can get more money. So this method is not considering the time value of money. That is a drawback of this method. LCOE LCOE is useful for levelized cost of electricity is useful for determining the rate of investment, choosing discount rate, comparing competitiveness of different energy installation, and calculating tax rebates.
I
Go through
think
the
we have
option.
covered this question, sir. Same question. Option C, comparing competitiveness of different energy installation.
Okay, I think yeah, we have covered it. So we have already covered today. So the correct answer is option C, competitiveness of different energy installation. A new oil well gives 100 billion barrel of oil. However, the cost of recovering the oil is equivalent to 30 billion barrels. Calculate the EROEI.
Sir, it's 3.3 coming.
3.3. Yeah. I think we have similar type of question we have already covered today. So just energy in or out, energy in upon out or energy out upon in.
Energy output upon energy input, sir.
Yeah. It will be 100 upon 30, 3.33. The EREOEI for oil has reduced from 90:1 in the 50s to around 5:1 today. What are the primary reasons? A. Wells are deep, requiring deeper exploration. Oil fields are getting smaller. Rigs have become complex and expensive, or all of the above. So, like we have already discussed it, like the EREOI has been decreased so much, okay, from past years. So, what are the main reasons? Go through it. Let me know the answer.
Sir, I think option D, sir.
Option D. Okay, just let's wait for 1 more minute. Meanwhile, you can explain your reasoning for option A, B, and C.
Sir, in lecture notes, we have, sir has covered that in 1950s, we have oil available very huge amount, like 100. Then after, as time coming after day by day, its values getting decreasing. Now totally
Okay.
we are 10 and 3.5 actually in recently. So there may be might reasons that oil fields are getting smaller and risks have become complex expensive. That's why I think option D will be correct.
Nice, nice. Good reasonings. So, as Alok also discussed, and I also discussed earlier, because due to the more exploration, due to the more like our, you can say we are using so much of energy due to population increase and due to our luxury and all. So we are exploring, we are basically exploiting the fossil resources. Okay. So wells are deep, requiring deeper exploration. Now we require deeper exploration. Oil fields are also getting smaller, and rigs have become complex and expensive due to more deeper exploration and all. We need more drilling and all, everything require more. That's why the cost is going up and the EREOI coming down. So the correct option will be all of the above. Input output analysis was developed by. So I think we have already covered it. It was
Option B,
Wesley Leontief.
Leonid.
Yeah. Okay. So these are the questions for today. Now we can revise some basic concepts. So in this week, we have covered these matrices. First was the EROEI. I think we have discussed it about. Then the payback period, then the return of investment, then the net present value, and the LCOE, and the input output method. So these three are not considering the time value money. Okay. And these two, net present value and LCOE, they are considering the time value money. Okay. So this is the diagram that's showing like another scenario. Okay, in like early 1800, the population was very low. Okay, as we are coming, the time is increasing, the population is increasing very rapidly. So around 1950, we discovered the oil. Okay, after that you can see there is a sharp rise in also population, in also energy and economy. So the economy is directly dependent on energy. Okay, if we have more energy, it means that we can have more economy, because we can generate more things, we can do different kind of things. Okay, so it will also give rise to the economies. So basically the energy is the master resource. So with energy, the economy can go up to like very high. So like energy increased 18 times, but economy increased 80 times. So this is the significance of energy in the economics. So I think that we have already covered like total energy or net energy. Okay. So because like if we are having some energy, like we are getting some energy from fossil fuels, but we have to also give some energy to extract that fossil fuels, like EROEI. Okay. So this I think we have already covered in thoroughly. Like EROEI is energy returned on energy invested. So energy out upon energy in. Okay. So if EROEI is 10, it means that percentage of total energy available will be 90%. So we have 90% of energy available, but we have invested 10%. So this is the diagram. So the surplus energy available to the EROEI. Okay. So if ERO is like very high, it means that maximum energy is available to us, or energy out, you can say surplus energy. Okay. That the above diagram, you can see this line. So the below one is showing the energy available or surplus. The above is showing the energy input that is required to generate that energy. So you can see that for wind and solar, we require very less energy. Okay, and we are having surplus energy. Okay, as compared to the oil, because if you see after this point, there is sharp decrease in the surplus energy and EROI. So like for oil, you can say in 1950s, the EROI was 100, because the oil was easily available. Just you dig like a small hole in the oil fields and you will get the oil. So you don't have to put so much of energy, like no energy at all. So that's why the all energy is available to you. So it was 100. Then 60s, 76, it was 25. Then 90s, it was 18 to 10. And today it is around 3.5, 10 to 3.5. Okay. So you can see the decreasing pattern. So for solar and wind is here. Okay. For renewables, we are having like for methanol, ethanol, and all, it is between 2 and 3. So the installation of an energy facility. So an energy project is considered to be economically viable if the following are satisfied. Like benefits are more than investment cost. Okay. Because the benefit should be more than investment cost, then only it's feasible. proposed project is more profitable compared to the alternatives. So suppose there are many alternatives, but your project is more profitable, then only it's feasible. Project can be scaled up to attain optimum economic results. So your project should be also be to scaled up. Like suppose your project should be able to go up to in megawatt scale, because whenever a new technology comes up, so first of all, the technology will be at you can say at very early stage in the theoretical development. Then the technology go to the lab scale. Then technology go lab scale to the bench scale. Okay. Then bench scale to a small demo, then from demo to the proof of concept, then proof of concept to the R&D. Okay, then proof of concept to the further R&D, and finally the market, or finally the commercialization. So these are, you can say, also TRLs, technology readiness level. So I think this vary from 1 to 8. So 1, it's a very early stage, like inception. 8, it's commercially viable and available. So your project should be like scaled up, so that it can be scaled up to like in megawatt scale, so that it will be attain optimum economic results. Payback period, like number of years required to recover investment from net cash inflow. So this is the formula, like T0 to N star, that will be the payback period. Cash flow T minus I should be greater than equal to 0. So I will be the initial investment cost. Okay. So rapid payback period is a prime criteria for judging an investment. So the whenever like an investor or any company want to install a project, they see the rapid payback period. So the payback period should be very fast. Suppose if you are investing some amount in any company, and you do the economics, then you will find out that you will get your investment return in 15 years. Then you will say no, it's not a good investment, because I'm investing now and I will get the output in after 15 years. So it's not a good investment. If they say that you will get the output in 3 years or 5 years, then you will ready. So that's the point. The payback period should be a judging criteria. It's a judging criteria, and it should be rapid. It should be very low. But the negative point of this is that it is does not consider the time value of money. Okay, so this affect the actual value. The return of investment, the return on investment is ROI, is the net annual return as percentage of initial investment. Okay, so net annual return, like how much return you are getting. So I think we have also done some numerical based on it. So the ROI is return on investment is S minus AO upon I. So S basically saving, AO is your annual operating cost, or you can say operating or operation and maintenance cost. Okay, and I is the initial investment cost. So you are having some saving annually, and you have to reduce like any recurring cost that is occurring. That will be operating cost, operation and maintenance cost, and all, and you have to divide it with the initial investment cost. So you will get the return on investment. Then the net present value. So cash flow streams. So cash flows in different points of time differ in value. Okay. So comparison is possible only in terms of a common denominator. This is the present value. So there should be a common denominator. The present value should be there. Not because we have already discussed is that if you are having some money today, you can invest in at like some for in banks or some FDs and some share market, so you can get more return. Okay, so we should do the NPV. So there should be a discount rate, or it can be like inflation index, rate of return, opportunity cost. These are some other name for discount rate. So the present value is basically the CF, the net cash flow at year n upon 1 plus R to the power n. So in this way, we can find out the net present value. The present value of energy installation, like for first year, it will be CF upon 1 plus R1, then CF2 upon 1 plus R2 plus like this, okay? Plus salvage value upon 1 plus R to the power n. I think we have also solved a question based upon it, okay? After putting all the cash flows value, the rates and time, you can find out the present value of the energy installation. Then you can find out the NPV, that will be the present value minus initial investment. So for economic viability, the net present value should always be greater than 0 and as much as high as possible. Then there is a levelized cost of electricity. We have also discussed this, like cost is levelized over life of a plant. Okay, it helps in comparing installation on a level playing field. So like we can compare a solar versus natural gas. Okay, because solar is like very high initial cost, but very low operation and maintenance cost. Like natural gas is very low initial cost, but very high operation and maintenance cost. So if you want to compare these two, the best thing is to compare with the levelized cost of electricity. So there is like a definition from EIA USA. The LCOE is an often cited as a convenient summary measure of the overall competitiveness of the different generating technology. Another from UK government, like LCO is defined as the ratio of NPV of total capital and operating cost of a generic plant to the NPV of the net electricity generated by that plant during its operating life. So like this is simple formula for LCOE, where the I is the initial investment, M is the maintenance and operation cost, F is the fuel cost, E is the energy generated. Okay, AO is the these are the annual operating cost. The unit will be dollar per kilowatt hour. This will be they are more complex. So in this we are also considering the depreciation, we are considering the tax rate, loan repayment, okay, interest on loan payment, annual operating cost, salvage value, and discount rate. For more detail, you can refer the class notes. Like we can also consider tax credits also, okay, discount rate like that. So basically, electrical energy multiplied by the LCOE gives the lifetime cost. So the cost will be like the now cost will be the installation cost, that is your current cost, and revenues, that will be the energy that you have generated from your system. Then there will be a price, and there will be tax credits, okay, carbon credits, and ongoing cost like operation. This is the cost that is ongoing, like operation, maintenance, fuel. So in these red box, you have to consider the future cost, because if you are comparing them with this cost, then you have to apply the net the money value method. Okay, so you have to convert into you have to apply the discount rate formula, and you have to compare it then. If revenue is equals to cost, then it's a break even. If revenue is greater than cost, it's profit. If revenue is less than cost, it is loss. So LCO is the minimum average cost of energy that one can charge, so that revenue earned by selling energy is equal to the cost of producing the energy. I think I've also covered a question about this. So any doubt as of now, Alok? Anyone, any doubt?
No, sir.
Okay, so we have covered some numericals and concepts. So but still we have some 10 minutes left.
Sir, in
So yeah,
sir, in assignment there is a question related present worth value. Sir, I don't know how to approach, sir.
actually we cannot discuss current assignments actually. We can only discuss the previous assignments, or we can discuss concepts. So if you have any doubt regarding concepts, then you can ask me, but that should not be from the current assignment actually.
Okay, sir.
So Alok, do you want to share your thoughts, because today is last class for this course? Because for tomorrow there will be like wrap up class. But if you want to share your thoughts regarding why did you take this course and all, what was the motivation behind you to take this course, and how this course is helping you?
As I told that before taking this question, this subject, I have read the all the syllabus, including in energy conservation basic recovery,
Okay.
is most matched with the GATE syllabus. That's why I approached to this course, and I am very thankful that many things I have learned from this course, and I'm very grateful, sir.
Okay. Nice. Nice. Thank you.
That very nice teachers are from IIT Kharagpur are explaining and clearing our concepts, sir.
Yeah.
And thank you for you, sir, giving the right direction for achieving the right solution our from assignment.
Yeah. Yeah. Thank you. Thank you. Thank you, Alok. So if you have any doubt, maybe you can ask me if you have any doubt regarding gate also, because we have 10 minutes, so we can discuss if you want, because that's also related to your, like, you are studying. Maybe I can answer that if you have any doubt.
Sir, please explain, sir, total energy base in net energy. I am confused, sir, right now.
Total energy, basically the net, and suppose the total energy, like in this EROA, I think this one.
Sir, lecture, sir, has written, sir, total energy base energy net energy. There is no difference I have get, sir. I am confused. That's why.
Okay, okay. Okay, so total energy, my suppose that you are there is a, as I told you, there is a tank. Okay, so this is the tank. So in this tank, oil is filled. Okay, so now you want to extract the oil. So how can you extract it? Either you can do it from hand, but it's not possible to do from hand because you need so much of oil. So what do? You will install a pump, like in our house. We are installing a electric motor to pump the water in our overhead tank. So you will install a pump here. Okay. So this pump will flow the oil to in the your other tank. Okay. From here you can take the oil and fill, like, refine it. You can do something with it. Okay. Is it clear?
Yes, sir.
Okay. So this oil is, you can this container is your oil well. Okay. This container, these are the barrels, like wooden barrels, in which you are storing the oil. Okay. So basically from these barrels you can use this oils to refine it, to do anything. So suppose these barrels having some energy like 100. So these barrels are having energy, they can generate 100 megawatt power. How much? 100 megawatt power. So this power is the total energy. So this much of oil can generate 100 megawatt power. But actually, but actually, to get this 100 megawatt, you have also installed a pump here. Okay, you cannot forget this. You installed a pump here. Okay, to generate this 100 megawatt, you have also applied some refining, and you have also, there is also transportation, and there are also many things involved. Okay, So if you count the energy required in those areas, suppose that will be 10 megawatt. So because if you don't want to extract this oil, then maybe you will never install this pump. Okay, you would have not done anything to generate this energy. So basically, you have would have not spent this 10 megawatt, but you spent it. You spent 10 megawatt to generate 100 megawatt. Okay. Now the picture comes. What is the net energy?
110 megawatts, sir.
No, 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 no. This is invested actually. 10 megawatt is invested now because you are running a pump. This require electricity. Okay. So you are require electricity. So this electricity went out. So what this work did? This work pumped the oil and filled your barrels. So this energy already gone in pumping. This 10 megawatt gone and you get 100 megawatt. So this is total energy. Now this is spent energy. This was the input energy, like input work. So the net energy will be 100 minus 10. So you have only 90 watt, 90 megawatt of energy. So this is the net available energy. So because if you want this 100 megawatt, then compulsory you have to invest 10 megawatt. But again, question, from where this 10 megawatt will come? Because you have only this source of energy. So this 10 megawatt will come from this 100 megawatt only. Okay, because you don't have any other source. So this 10 megawatt is also coming from this 100 megawatt. That's why you will use, like you have, like you fill like maybe 200 barrels of oil. Then what will you do? You will use 10 barrels of oil to generate this 10 megawatt, and remaining barrels will go further. That will equivalent to 90 megawatt. This is the concept of total energy and net energy. Is it clear?
Yes, sir. Thank you, sir.
Yeah, good. Okay, Alok. So almost we have covered. So thank you for joining, everybody.
Thank
Thank you all. Thank you for joining the session, and I hope you learned a lot. So with this, I am ending the slide slow. And another announcement for you, everyone. Uh, Tomorrow we are having another session. Basically, in that session, we are going to discuss the all 12 weeks questions. So that will be a very good revision for you. So I hope you will join that session. The timing will be same from 7 p.m. to 9 p.m. tomorrow. I hope you will join and you will be benefited from that session.
sir.
So with this,
Sir,
yeah, yeah.
actually, when we have a live session, we get, sir, an email from the NPTEL. So there is another live session tomorrow. So we will get another
Yeah,
new mail, or sir, we will
yeah.
active.
There will be a new mail. There will be new mail. Yeah, I think the mail has been already sent. You can check your inbox.
Okay, sir. Thank you, sir.
Yeah, yeah. Okay, okay. Thank you, everyone. Have a great weekend. Okay, thank you.